So when the customer came to us with his requirements, he told that he wants microservices because we want some parts to be scalable. Then we might experience many users. Another thing is that part of our team was planned to be in Scala, working with Scala. And in Scala world, they prefer using Akka streams, which is also reactive. And another point which we considered is that our project was new. So we could actually choose any technology which would fit with everything that goes with the requirements. So thinking gave us a solution that was reactive streams. And for sure, every one of us knew what Sprint data was, what how to work with Sprint. So we thought that probably we don't want to stick with Scala because our customer proposed us to work with Scala. We picked Java 11 version and decided to try that with functional approach. And because thinking that reactive streams work with native in Sprint, we thought that that might work fast, which will fit the goal of our customer to process many requests. Then, Here is how our project was supposed to look like. So at first we would have some users that would log in using web gateway. Then we would have some services in Java with reactive streams and web flux, and some services in Scala. For sure, you can go without a database. Database usually is standard for pretty much any project. So one of our databases was reactive. We thought that probably, as far as we didn't see all the picture, that customer, you never know what you expect in future. And the requirements were not so stable. So we decided to try MySQL. And also we had requirement to store some big data, which would be stored in NoSQL database. Relational database would be used mainly for querying some indexes. So how can you work with your relational database and still be reactive? There is a solution which is called R2dbc, reactive driver for database connection for relational databases, and some peculiarities that it has. So first of all, it is non-blocking, because actually there is no reason to have all your flows reactive, but the database as a bottleneck, which processes all the queries in a standard way. So what we wanted is it to be scalable, and it is possible with Neo. I will tell a bit further about it. And also there is API, so in case you need, you can override it, you can override some methods, you can implement your own R2dbc, and I have attended a talk today about how to write your own reactive driver. So we thought that this solution might work really well, but and also what was important that it supported our database which we picked. Also it supports H2, so we can run our tests using H2. Microsoft Server, it is good, but not for us. Postgres, I wish we were using Postgres, but our customer chose different. So when we started really doing our project, we faced some issues. First of all, there was not, our customer didn't give us requirements that every library that we use has to be release version. We didn't think of that. So the driver which we started using was not released yet. It is milestone. And what we didn't understand from the first was that somehow they move from first version to 0.8 version. And Maven would mark it also like Maven also thinks that 1.0 is a bit higher than 0.8. But you have to pay attention to the date when it was released. So we had some issues with Spring because the versions didn't go together well. But when we downgraded to 0.8, it worked well. So, and now we are still struggling with the limitations on our customer side with his servers, that it constantly appears that we use milestone or snapshot versions, and also it is for our API, for Swagger. Swagger also supports Reactive, which is good, but unfortunately it is very, like, not ready yet. It is still snapshot. So sometimes we have issues which we have to handle manually. And speaking about transactions, at first, we were doing everything in transactions. We were using Sprint data, which was very comfortable. But the limitation is that not all Sprint data works really smoothly. Speaking about Sprint data, it handles a transaction by itself. So at first, it would send a start transaction, then it will execute your query, and then commit or roll back depending on what happens. We also were using transactions manually. It is not complicated. You can implement your query in transactional method, and it works pretty much same. But to be honest, when we started our releases, we figured out the issue with many data. When we started returning several thousands of records, or several tens of thousands of records, we realized that the response comes in 7 minutes. 7 minutes wasn't acceptable. Honestly, we didn't test it because our customer provided us the real data, but it was probably pieces of real data. But the actual real data looked much bigger. So we figured out it on the late stage, and the solution which we could do is to remove the transactions. We started doing everything without commit and start transaction, and honestly, it showed nice result, and we started returning those big results in less than 2 minutes. We also had some logic connected with processing those big results, so it also influenced the time. Then to speak a bit more about Sprint data. Again, this is just the start. Reactive Streams started working around a year ago. So the basic methods like find by ID or save all, they do work. And you don't need to write anything. But in general case, if you want to find something by general field, like by user ID, which is not the key in the database, you will have to write your own query. And with time, we figured out another issue. I would imagine that all the parameters would be mapped by the IDs, which is specified, but this is not the case. For example, if you would like to check if your user ID is in some range and you would want to implement some kind of such query, you would have to pass the user ID twice, because inside it would have not map, but the list, and every parameter would be mapped by its number in the list. So we fixed it by just passing user ID twice. Probably it's natural, but it's not what is obvious. And so let's think if it is still better to use JDBC or R2dbc, and is there a real difference? So at first, when I was imagining myself Flux or returning a large amount of data, I would think that it would be returned in parts. So as soon as some little part of data is received, it would be passed further. But honestly, this is not the case, because this is not how databases usually would work. So we figured out that the whole set of data is returned. The main difference between using JDBC and R2dbc is that at first you would either hold the thread, JDBC holds the thread until it's done, until the result is returned, and then it passes the result further. But when it comes to R2dbc, the thread comes, it gives a request, then it leaves, and it is able to accept another request. That's how scalability is managed. But when the result is returned, another thread, or maybe the same one, but any thread would come, fetch the result, and pass it further. And this is all done by having Neo in the basics of R2dbc and event loop, which listens to when the result is returned. So to sum it up, we are already using all this stuff, and we are almost in production. Like, we have already released our product to MVP, and we hope it will work well with production. We still need to be ready with some functionality. So for now, it's well. So I can advise you to give it a try, and hopefully there soon will be a release version of R2dbc. Here are some useful links, and thank you.